This video is going to go over the factoring book project. So we're basically creating a book here, and it's going to basically be able to teach someone how to factor. So our instructions are that we need to create a colorful and creative book explaining each of the methods used to factor different types of polynomials. Now, I'm not really sure why there's a colon there. I might have to go in and fix that. But polynomials, again, that's just a fancy word of calling anything with one or more terms. So each factoring method will contain two parts. You're going to explain either using steps or sentences, so complete sentences or steps, of how that type of factoring is performed. So if you were to explain factoring when A is 1 to someone, you need to be able to put that into words or at least put it into steps for someone to understand. You need at least 3 examples of each type of factoring with the correct answers. Now these examples could be pulled from the homework, from the notes, on the internet, any type of example that you want to use, or you can create your own example. And so if you really want to create your own example, one of my suggestions would be let me just create 2 binomials, right? Random 2 binomials, anything you want to pick, and then double distribute that, right? So then I'd have x squared, negative 4x, positive 3x, and then minus 12. So then I would combine my like terms here. Negative 4x plus 3x is going to be negative x minus 12. So one of the examples I could use is I could start here and then show someone reading the book how to go backwards. And so you could create your own examples, but you do not have to. So I would recommend pulling from maybe problems in the homework or problems on our notes. Okay, so there are 4 different types that we've talked about, kind of. So the first type that we've talked about is factoring when there's only a GCF. So sometimes when we're given a polynomial, the most that we can factor is a GCF. An example of that would be from the warm-up, right? So no, that's the wrong warm-up. So from number 3 in the warm-up that you just did, there's only one thing that I could do, and the only thing I could do was factor out a GCF, okay? That's the most I could do. I couldn't keep factoring, so that I had to stop there. So that would be an example of only being able to factor a GCF out. So you would need 3 examples of that. So 3 examples explaining just factoring out a GCF. And there are examples available for you to look at. So if you want to just look at different examples and see what other people did, you can. Now, you want to make sure that you don't copy them because plagiarism is not allowed and it will be taken seriously, and I will have to give you a 0 for something like that. But you are able to look at it and be like, let me see what this person did so I can, see what I want to do. All right, the second way is just to factor by grouping. So if you want to just use your notes for factoring by grouping, you can look back and be like, well, I know I need 4 terms. So if you wanted just to use maybe example number 2 from the notes, now hopefully not everyone uses example number 2, but for example, if you want to use this one, this would be you already have 4 terms, right? You don't have to make it into 4 terms. You already have 4 terms. So this is when you already have 4 terms, and then you just factor by grouping. You don't have to create that. You don't have to use the AC method. And again, you would need 3 examples of this. Okay, the next way we learned how to factor was factoring trinomials, so when we had only 3 terms. And regardless of whether A was 1 or when A was greater than 1, you still did the same thing, so I'm okay that you combine this into one page or one section in your book. So this could just talk about, you give me 3 different trinomials, and maybe one of them has A equal 1, and then the other 2 A is not 1. But you do want to mention that, hey, every single time I factor, I always check for a GCF. So that should be your first step on every single page or every single type of factoring that you have. So again, you want 3 examples for this one. You can either do 2 for when A is 1, or 1 is greater than 1, or when A is greater than 1, or you can do 1 of those and 2 of these. But in total, you need at least 3. Now, you can do more than 3, but you need at least 3. Okay, the last factoring that you learned is special cases. So we have 2 types of special cases, difference of squares and duplicate factors. The difference of squares method is the one where if we have we know that we have 2 sets of parentheses, we put opposite signs. So let's say we have something like this, right? And then you would square root the first one and you get x, and then you square root the last one and you get 3. So this was the difference of squares method. And remember, you want to look back at your notes because you want to be able to explain and teach someone that. So you want to be able to put into words, be like, this is why you do this, but it has to meet these certain requirements. The duplicate factors is basically once you finish all the factoring and get to the very last step and you get to an example like this, right? So we had something like that in the warm-up. So let me go back to that. Oops. So like this one, right? We started off with a trinomial and we ended and we got to these two factors. Well, once you notice that they're the same, you need to condense it into one binomial squared. So, I keep clicking on the wrong stuff. I'm so sorry. So here, since we have x plus 5 and x plus 5, then you do x plus 5 squared. So this is another case of duplicate factors. And I would need at least 3 examples of these. And you can either do 2 difference of squares ones and 1 duplicate factors, or you can do 1 difference of squares and 2 duplicate factors. But you need 3 examples of them in total. So you can have 2 of that, 1 of this, or 1 and 2. Okay, so again, same thing with these two. You just need 3 in total. I don't need 3a equals 1 and 3a is greater than 1. We just don't have that kind of time, so I'm okay if you just do 3 examples of those. So in total, in your book, you should have 12 examples, 3 going over GCF only, 3 grouping, 3 for trinomials, and 3 for special cases. Okay, here's the guidelines. These are things that are must do. So notebook paper can be used to make the cover or make the book, but if you would like to use colorful paper, you may, and I have that provided for you if you would like to use that. You're going to also make sure that you put your name and the title on the front cover. So I just need to be able to see your name and know that it's your book. If you turn it in, I can't give you credit for it if I don't know who it belongs to. It will be graded on creativity, neatness, color, and explanation. So I have provided color pencils and markers, and you can choose to use your own stuff too. Really, we won't have much class time to work on this, but on review day, if you have time after you finish your review, you may work on it. It is due on the day of the test, okay? I am not going to accept anything late. It is a quiz grade, so if you do not have it turned in to me on the day of the test, I'm not going to accept it because I cannot accept a late grade on a quiz. But that's pretty much it. Creativity could be anything. So there's some books up there that are kind of silly, and there's some books up there that are pretty straightforward, and the cover is kind of creative. So just some type of creativity anywhere. So either on the front cover only, or just throughout the book. And it can be an inside joke, maybe we have within the class, or whatever you want to do. So that is it. And then this is your rubric below, so you can see like where all your points are going. And yeah, again, factoring book project is not super difficult, and again, there are examples, so you can just reference to that as well.